All right, folks, this is the dramatic conclusion. This is it. We are going to take the Bluefruit data logger code here, and we are going to combine it with the Bluetooth code. Okay, so I'm not entirely sure how I want to do this because right now it's running the Bluetooth code, and most of it's already in here. So I think I'm just going to grab the data logger. Well, so here's the thing: is like all of this pixel stuff is kind of nice. I think I'm going to go back to the data logger code. Okay, and so I'm going to delete the Bluetooth code, run the serial, and let's see what it says. Serial. We need to reset it. The LED is blinking, so it's definitely doing something. It should say not opening file. So here's the thing. Right here we output to a file. I actually want to always read the data, because eventually I'm going to send the data via Bluetooth, right? So I'm going to tab this over like that, except for the print to file, and the printing to the file and changing the pixels is only going to happen if I flip the switch, okay? And I'm also going to print to standard out just because for debugging purposes. Okay, so there we go. So it's not opening, it's not writing to the file, and if I flip the switch, it'll throw the error that it's a read-only file system. And if I flip the switch back, it's going to enter the REPL, and so I have to hit Control D for it to start running again. Okay, so now let's start getting all of the Bluetooth stuff. So I think these are the only modules I need for Bluetooth. Here's the UART send. So I'm going to go back over to code and up to the imports and pull those in. And so everything's still good. Then I'm going to scroll down. I need to set up the Bluetooth. So I'm going to copy that and bring that over. So let me comment this a little bit better. So let's set up LED. Let's set up the switch. Set up the pixels, set up the thermistor, set up the accelerometer, and then down here we can just set up the Bluetooth. So all the setup happens before your while loop. And then here, this is where we, check for opening file. Okay. All right, and then let's see. So I have the Bluetooth set up, so that should be in there. And then I set up the thermistor, I set up the accelerometer, that's all the same. And then this is where, in the while true loop, I need to start advertising, okay? So this is where things are gonna start to get awry. So I want it to only, see, I'm concerned that if you have I always want it to log data on board. Yeah, so can we do this? Can we always take data, and I don't want to enter into a infinite while loop. What I want to do, I think there's an if statement over here, right? Bluetooth stop advertising. Yeah, while BLE.connected. Okay, that's what I want to do. So what I want to say is if BLE. Is it not? I already forgot it. So I'm going to say if not BLE connected, I want you to print that you're not connected, and I want you to start advertising. And then I don't want you to enter into this infinite while loop though. Hopefully this isn't going to break it. And then I'm going to say if or else, I'm assuming that you've now connected, I want you to stop advertising and say, hey, you're connected. Now, is that going to freak out? Invalid tense syntax line 75. Oh, it's because there's a colon missing. So is that going to freak out? It is. So it's already advertising. Okay. So I need to have a check and say, I'm going to say some booleans, okay? Advertising is false. Okay? So if we're not connected, we'll say we're not connected. If advertising is false, I want you to start advertising. Okay? Otherwise, say you're connected, and then say advertising is true. Okay? Now, let's see what that says. I'm terrible at this word, advertising. It's a long variable name. If advertising is false, here, you know what, I'm just going to copy this, and I'm going to put it here. Sorry. I need to put this here. If the advertising is false, start advertising. And then I'm advertising. Once I'm connected, you need to say advertising is false. There we go. That way, if you for some reason lose connection, it will start advertising again. There we go. Okay, I think that should... No. What the heck? I spelled advertising wrong. There we go. Okay, so it's printing and it's not connected. Now, I'm not going to superimpose my phone this time because you've already seen it. I'm just going to walk you through what I'm doing. I'm going to open the Adafruit Connect app, and let's all pay attention to this not connected down here. And when I connect, let's see, BLE, Bluefruit Connect, I see the CircuitPy. I'm going to hit connect, and it says connected now. Haha! All right, sweet. Okay, so we're somewhere. So if it says I'm still connected. If I open let's open the Adafruit app again, and go back. Now it says not connected. Okay, cool. You know what'd be neat? I'm going to say not connected, else I'm going to say print advertising. Advertising. Okay, so now it should say not connected, I'm advertising. And then once I connect on my phone, now it says connected. Okay, and then if I back out of that, it'll say not connected, I'm advertising. Okay, this is so slick. Okay, so now if I'm connected, so if not BLE connected, stop advertising, and oh, by the way, I want you to send some data. So here's this. I want you to send all of it. UART server 1, 2, 3, 4, 5. And I want you to send T, X, Y, Z, and temperature. Okay? So now I'm not connected, I'm advertising. I'm going to connect. And now it should say that I am sending data. So if I click the UART, sure enough, I am getting data on my phone. Okay? And if I back out of UART and back out of the module, it says it's not connected. Okay, cool. So now what I want to do is see if I can flip the switch, log data to the CircuitPlayground, and send data to my phone, download both data files, plot them both, and see if they match. It's going to be really hard. Okay, so bear with me. All right, I'm going to flip the switch, and it's going to say file is not defined. I am going to reset the device. Okay, and then now it is taking data. All right, so you see that remember the pixel is running. It's writing to the file because we know the pixel is going, but we're not sending data to the phone. So now I'm going to connect on my phone, and I'm going to open UART, and now I should be logging data, and I am, and I'm just going to do like a figure 8 pattern, okay, while I'm logging data to the phone, and it's logging data to disk. Okay, so now let's see. What I want to do is flip the switch, boom. So now I'm not logging data, and then I want to export the data on my phone to a CSV file and post that in the Google Drive. and put that in the main root folder, select, save, okay? And then in order to get the data off of the circuit playground, I need to, so let me get rid of the connection. So now it's going to say not connected. And I'm going to reset the device. In order to get the phone or the data from the circuit playground, I need to reset it after I flip the switch. So now there should be a CPB data log file, and there's 1,000. So this is kind of neat. I've had the circuit playground plugged in for a really long time, and so that number 14,338 is pretty specific to these experiments that I've been doing. So I'm going to rename this CPB data log with BLE. Oh, that's BLKE. BLE, okay? And then now, off camera, I'm going to go back to my Google Drive, and I'm going to download to my desktop that timestamp mode file. And so there's the timestamp mode file, and I'm going to rename this. For some reason it puts commas in here, which I just don't like. Timestamp mode, and I'm going to say with data log, okay? And so now what I'm going to do is I'm going to open Tony again. And what we need to do, well, actually, before we open Tony, we need to look at these files, okay? So here's CPB data log, okay? So that looks pretty standard. Time, X, Y, Z, and temperature, okay? I mean, I was the one who wrote it, so obviously it looks good, right? Then I'm going to open the timestamp file, okay? And so here's the weird timestamp file. It looks like it's doing exactly the same as before. It's doing one row with X and Y, and then it's doing, oh dear, this is terrible. I see what's happening. That second row was not an integer. It was the rest of the decimal points from the y-axis. Oh my goodness, interesting. But there's never a decimal point. So what we need to do is we need to take this number. Oh boy, this is going to be so freaking complicated. Because see, here's two decimal places. No. I can just do string concatenate. So what I'm going to do is I'm going to take this value as a string and this value as a string and append it together and then convert it to a double. Okay? So that means the last video is wrong. Oh dear. Okay, so let's open Tony. And let's grab the code that I just wrote. Let's see, Git repos, GitHub, microcontroller, Circuit Playground, CircuitPython, CPB data logger, plot BLE data. And let's just edit this code here. So I'm going to type in /home/Carlos/desktop. No, I don't want to do that. I want to move this over later. I will move this over later. Okay. So I'm going to open this, Control-C, close, and then paste this in, and then I'm going to save this to the desktop and call this plot ble data.py. Okay, and I'm gonna fix this on the fly. So right now it says timestamp mode.txt, and that's because the name of the file is with data log, and I'm gonna hit run now. And it ran okay. The time is totally messed up. Oh boy. So something happened. So between the last file and this file, something happened. So I think what we need to do is go back to our debugging, and let's say valid packet received, and we want to print the first second row and see what's going on here. All right, so we've got so we've got valid packet received. Oh, okay, hang on, I need to comment that out. There we go. Okay, and we have empty arrays here. So we've got valid packet received 1,400. So I mean that's time, and that's the first row 0, 1, 2. For whatever reason, the time is all messed up. So what we need to do is, let's move this down here and put that there and put this here. And we just need to look at our time data and see what's going on and why it's not working. I'm going to get rid of all of these plots and hit run, and we should just see it kind of pull in the data. And then what I want to do is I just want to look at t and just maybe plt.plot t and then plt.show. Okay, so it looks like at the beginning it's grabbing some zeros, and then it grabs some good data, and then it drops out again. So for some reason at the beginning, it's, oh, you know what? Okay, so here's the other issue, right? So my check for the first and second row is that this number, when you round it, it's equal to itself, right? So that's actually not true. I think if we get a data packet that has a length of 5, no matter what we need to do is we don't even need to do this time.double in here at all. The question is like, how do we know we got the first row, and then how do we know we got the second row? That's what's kind of frustrating. Yeah, see, look at all this mess down here. Like, what happened there? I mean, that's definitely 2 valid packets back to back, and that's 2 valid packets back to back. Oh man, you know what? I wonder if this third packet it's 0101. 230101, yeah, and this is 230754. So okay. So is it always 3? 1, 2, 3, 1, 2, 3. That's what I was thinking. I thought it was always 1, 2, 3, and that was what I did in the last one. I mean, basically, what you need to do is you need to remove this, and then append the previous data packet. It's like you can it's almost, yeah, you can tell. So the Bluetooth can only send a certain length data packet, and that's why it's this long here. So it's not if it's equal to 5, it's really more just you need to check this first one. If it's time, it means you got a new row. That's what I need to do. It's not always 3. It's just if this is a valid timestamp, then that means you got a new row. But how do you tell the computer that this is a valid time packet? There's got to be some sort of edge case here that I can come up with, because it's not even length of 5. What you need to do is you need to grab this guy, and if that is, I mean, I guess I could look through the data. I could do that. If the number is between, yeah, I could just do that. I mean, that's pretty terrible, but that'll work. So I don't need to check and see if the length is 5. Oh man, so I at the expense of writing all this over again, I kind of want to do this over. What I need to do is I need to basically have like a new packet, right, is equal to an empty bracket. And what I want to do is I want to grab the time flag again, and that's a row of 0, 1, 2, right? Let's see if that runs just fine. Is that going to throw an error? No, everything's fine. Then if I'm going to say yeah, time flag. I'm going to convert that to a double, okay? And let's see if that throws an error. Okay, it tried. So I'm going to try, okay, to convert this to here, and I'm going to say except. I don't want to do that. Let's do the time flag. So time flag is, I'm not going to convert it to a double yet. First, I'm going to see if the time flag is greater, if the length of time flag is greater than 0, then convert the time flag to a numpy double. Let's see if that works. Is that going to throw an error? Yeah, it did. It's the first row, the timestamp, yeah, the data. So the issue there is that I'm going to say and time flag does not equal data. Let's see if that's okay. If that will let me do it. Okay, data / n. Let's see if that worked. Okay, yeah, so if time flag is greater than 0, but this is not greater than 0, I want you to print me the length of your time flag. Because it's 1. Interesting. Okay, I guess I'll put a and time flag does not equal an empty bracket or an empty array, and then run that. Blast. And time flag does not equal empty spaces. So what's happening is that I get down here and there's nothing there, right? And it freaks out because it's like, hey, it doesn't exist. You know what I can do is I can say, do one more check and say, what I'm trying to do is identify this number, okay? And if it's not that number, then I need to append to the new packet. That's essentially what I'm trying to do. And so if all of this criteria is satisfied, I guess what I can do is I can say like, hey, if the length of the row is less than 5, then convert this guy to a double. That should work. And so if the length of the row is equal to 5, then you convert it to a time flag. And then what I'm going to say, if time flag is greater than, let's say, 14,355, and time flag is less than, and go all the way down to the bottom, and say 14,381, so I'll say 14,382, then I'm going to print new packet detected, and then I'm going to go ahead and print the row. And so hopefully we should see a bunch of new packets, and I think we got it. Okay. Wait. Oh, I scrolled up too far. Okay. So that means we got a new packet detected, which means we need to say new packet is an empty bracket, and then say new packet is row, like that. Now, if this is not if any of this is not true, okay? So if the length of the time flag is not greater than 0, this time data thing, I need to make sure, I need to move this up. This needs to come up here. If time flag does not equal data, then do all this, and tab that over once. So if it's not a data row, if the time flag is not greater than 0 and it's not equal to 5, and it's not in any of this, like if any of this is false, I got an idea. So if the length of time flag is not greater than 0, then you need to append. I'm going to create a function called append packet. If the length of the row is not equal to 5, then you need to append the packet. Okay? And then if the time flag is not within this value, then you need to append the packet. Okay? And then I'm going to write a function up here called def append. And I guess what I'm going to do is I'm going to send it the packet. So I have, this is getting nasty. So I'm going to send it the packet, and I'm going to return the packet after I've done stuff to it. So we've got packet, 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 and so I want to say packet equals, and I'm going to say packet equals packet, and then packet equals packet. This is really bad programming. I have the exact same line of code in 3 different places. That's terrible programming. But it's all I can do right now, okay? I don't want to print the row anymore. I want to print the packet, if this works. Okay, so right now, when we print the packet, got an error. When we print the packet, we should just see append packet's not defined. Oh, dude. I don't want to use append because append is a built-in function. Okay, so new packet detected, and then you print the packet, and then you erase it, and then you reset it. Okay, so right now this is the only packet here. All right. What we need to do is if we get a new packet, we need to strip the first 2 rows, then take this guy and add it to the previous one. And we also need to get rid of this /n business in here. So first what we need to do is we need to say print packet of -1. Ooh, wait a second. You need to give it the packet and the new row. And the new row. See, this is why this is bad programming, because I've got to write the same thing 3 times. Like, this is just terrible. So what I want to do is I want to print the last value, and I want to print the row of 0, 1, 2. Okay? That's what I want to do. And what I should see is, yeah, -9, and then 42295. And then -9, and then 61. Okay? Now, I'm not seeing the temperature. Oh, that's because the temperature is part of this packet. No, but I should see like a... Oh, okay, the packet is not growing. That's what I'm saying. So this is -9.42295, 42295, and then it's 20.61, 23.20, 61. But since I'm not appending the packet yet. Okay, so this is good. So what I want to do is I want to I want to print row of 2 to everything. Well, hang on. First I want packet of -1 and row of 2 to merge. Okay, so I'm going to say packet -1 plus equals row of 2. Okay, and then I want to packet.append row from 3 to wherever. And this is probably going to throw an error because it's going to say like, hey, it's not long. Oh, it worked. Okay, so here's a new packet that has been detected. So there's -9./n3 whatever, and then there's all this. What's that 7.2? So this is what I want. That's fine. And then it appended this packet, and it appended the whole list. I guess I should say for x in range 3 to len of row, and then say packet.append row of x, and then get rid of this. Is that okay? Okay. So now we've got the time, x, y, z, and then temperature with all the decimal places. Now we need to get rid of the /n's. So what we need to do is when we grab the row, we need to strip the /n's. So for x in range 0, len of row here. So do I have a packet? So packet of 0, 1, 2, 3, 4. So 4. And I'm going to say packet of 4 equal to /n. It's going to say false. I accidentally just printed this. I want to say, you guys, again, I'm sorry this video is so long. Packet of, I'm going to say, is /n in packet of 4? I'm just going to say true. And can I say, like, packet of 4 dot replace the /n with an empty bracket? Yes. Okay. So in here, I'm going to say for x in range. If a /n is in, oh, sorry. If a /n is in row of x, I want row of x dot replace the /n with a tick mark, and then run that. Damn. Okay, so now it's saying that it doesn't exist because the only thing that was there was a /n. I'm going to say if len of row is greater than 2, do all this. Otherwise, just return the packet. Because since I stripped the /n's, if len of row is greater than 1, greater than 3. There we go. Okay, we still have some /n's in here. I don't know why. This one's fine. I don't really care about that one because that's at the very end. But there's still a /n in here. I guess I'll say if /n in packet of -1, packet of -1 dot replace. Just do it twice. See if that works. No, it's still got this dumb /n in there. Because here's the thing. So if I type in packet, right, and packet of 0, 1, 2, 3, 4, right, so 4. If I try to do np.double of packet of 4, it's going to freak out. And if I do packet of 4 dot replace /n with a tick mark, okay, maybe let's do this. Once you have a new packet, it's time to grab everything. Okay, so let's run this again. And let's say, okay, t dot append packet of 0, 1, 2 dot replace /n with an empty bracket. And then x dot append packet 3 dot replace /n with an empty bracket. Y dot append packet of 4 dot replace /n empty bracket. Z dot append packet 5 dot replace /n empty bracket, and capital T dot append packet of 6 replace /n empty bracket. And let's see if that works. Index out of range. New packet detected. Is it because the first time it runs through the loop there's nothing in there? That's what it is. So you just need to check and make sure the packet's actually valid. Let's see, int object has no attribute append. Oh, because I did that, oh, of course, I need to do for I in range, for I, because I just renamed that variable basically. This code is getting gnarly. Okay, I don't have any errors, so I convert everything to numpy arrays, and then I plot. Come on, baby. And run. Give me plots. No! This is terrible. Oh my goodness. Alright, what is T? I converted you to a double. No, I didn't. Oh, Carlos, I didn't convert you to a double. Oh my gosh, you guys. You know, you're seeing the frustration. This is a gnarly code, but maybe someone will get benefit from this? I have no idea. This is crazy. You know, you would think whoever wrote the Bluetooth module would, I don't know, maybe send the packets better. I mean, I guess it can only send so many characters at once, right? I mean, I think that's what's happening. Yes! Yes! That's what I'm talking about. Okay. That is clearly me waving my hand, okay? So the question is, all right, let's do in dashes, because this is going to be Bluetooth, and dashes. Now what we're going to do is we're going to do the easy one, which is where we import, and where did that data go? We're going to import the CPB data log, and that is going to be, oh my gosh, so many simple lines of code. So now, oh wait. Let me, so this, I'm going to save this and hit run, and we should see dashes, okay, because that's Bluetooth. I'm going to make a new script, and I'm going to Control-A, Control-C, Control-V, and I'm going to save this as plot BLE and CPB data. Okay, so this is plotting both, all right? So here I'm going to import the onboard data, okay? So this is going to be data is np.load text. Watch how easy this is. CPB data log, it's a capital with BLE, oh gosh, BLE.txt. Okay, I'm gonna get rid of these prints because I think it's bogging down my import. There we go. No errors. I have pulled in data. Data is an array here, and so I should just be able to do T CPB is data of all comma 0. X CPB is data of all comma 1. Y CPB is data of all comma 2. Z CPB is data of all comma 3. And T CPB is data of all comma 4. And if I run that, no errors. Awesome. And then everybody drum roll please. plt.plot T comma X CPB. And then plt.plot T comma Y CPB. And then plt.plot T comma Z CPB. And then plt.plot T comma T CPB. And everybody cross your fingers. Blast. Oh, TCPB, 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 let's not mess this up here. CPB. Run it. Oh, man. Okay, so what I think I'm seeing is I was logging data for about, I don't know, 20 seconds before I started sending data via Bluetooth. It also looks like there was some discrepancy here. This looks something looks off. Not entirely sure what happened. But once we kind of hit our stride, Bluetooth and the this is probably parsing. This dashed lines, it's got to be parsing. I bet you my parsing script is not perfect. But the point is it looks pretty good. And then it looks like I stopped data logging and then stopped Bluetooth. So then if we go to the accelerometer plot, this looks freaking cool. So yes, I was logging data before I turned on Bluetooth. And then I turned on Bluetooth, and that looks almost perfect. And then I turned off data logging and kept logging via Bluetooth. But you now have code that can log via Bluetooth, send it to your phone. You can download that data. You can parse it with my crazy parser. You can also log data to the CircuitPlayground and plot that data. So at this point, you have a pretty stout data logger that will log temperature and accelerometer and time to your phone and to the accelerometer. So I hope this helped, and I'll see you in the next video. But this concludes the series. I hope you enjoyed it, and take it easy.